To understand this concept further, we take a concrete example of a function and we see that how we can use the recursive definition of the function to compute its values. Okay, so as mentioned previously in the previous slide, we said that we will define a base value of the function. So we start off with defining the value of the function at n being equal to 0. Okay, so you can also start from 1. It depends upon the domain of the function, but it has to be integers for recursion to make sense usually. Alright, so we define the value of the function at n equals 0 to be equal to 3. Okay, and the next value of the function is then defined in terms of the present value times 2 plus 3. Now the idea is that we are given the value of the function at n equals 0 already, but for all other values we may have to consult a previous value. Okay, for example, to compute f the value of the function at n equals 1, we double the previous value, which was 3, and then add 3 on top of it according to this formula. So we have 2 times 3 plus 3, which is equal to 9 as the value of the function at n equals 1. Similarly, at n equals 2, we double the value of the function at the previous value, which was f of 1, which is given as 9. So we have 9 times 2, and then we need to add 3 on top of it to get the value of the function at n equals 2. Similarly, we define the value of the function at n equals 3 and n is equal to 4 as doubling the previous value and adding 3 to the resulting value after doubling the number. So this way you can define this function in a very simple manner as a function of itself, but for a previous value in the domain.